Good morning. This video is to assist and give a demonstration of what I'm looking for the second portion of the visual inspection, which is the measurement portion. I'm going to split this up into two different sections because the students, all of you, are currently in either the CWB elective or in the pipe elective. So I'm covering both bases, and what I'd like you to do is get yourselves prepared with a couple of plates. You're going to take some measurements. You're going to take the Excel spreadsheet that I have supplied to you, and you're also going to take the mock spec that I have supplied as well. Now that mock spec has some plus minuses, some parameters, and that type of thing. One thing that I should note is if it's not in the mock spec, if there is something in that mock spec that you see on the plate or in your pipe that is not in the mock spec, it gets disregarded. You can add it in as an additional at the bottom of the page if it's egregious enough that you feel that it needs to be noted. That's fine, but it is not something that has to be added. Okay. So how I'm going to split this up is I'm going to start with the pipe, run through the pipe a little bit, and then I'm going to run through the plate. And the reason for that is I've got a welded plate here, whereas I don't have a completed welded pipe to show you, but the descriptions are very, very similar. The other thing I'm going to note is that I have actual 4-inch sked pipe here, right? This is 4-inch sked 80 pipe. You may either use this, which I'm not sure if you started to do this yet or not, or you can actually use the 3/8 rolled flat bar practice pieces that you have been working on. And the reason for that is, I don't have the rolled ones, okay? You can use those 3/8 rolled ones. The measurements are the same, but when you go to do the measurement after the fit up, I would like you to do it after it's rolled, not before it's rolled, because there are changes that can happen after it's rolled, okay? Root gaps can change if you have a tack that breaks when you're rolling it. Those things have to be noted because that is the finished fit up before you weld. Okay, so I'm going to run through the measurements and that type of stuff with this, but you can use the 3/8 rolled flat bars. Just make sure you do it after it's rolled. So we'll start with the pipe. You will start with the individual pieces before you roll them because they're the individual pieces, right? So there's a side A and a side B, obviously, because you're going to have a weld joint that has two pieces, a left and a right. So you're going to take your cam gauge and you're going to start by measuring the bevel on the pipe. That's fairly easily attained by simply going until there's no gap. Okay, I think we're there. No, right there. Okay, no gap. And the spec, I believe, says 30 degrees plus minus 5. Well, we have just about, try that again. Yeah. We've got just over 30, look, on this piece, we've got about 37 degrees. Well, that's outside the spec, so you would note that. Okay. The also is the root face. You're going to measure the root face. Now, a quick and dirty way of checking the root face, if it's supposed to be 1/8, grab a piece of 1/8 electrode. Grab a stick of 1/8 electrode. Is it the same width across the root face? Great. If it's the same or very, very close, you're good. If you're not, then flip over your cam gauge, give it a quick measure, and find out. The root face on this is probably only about a mil and change. Yep, this is just over 1 millimeter. Okay, that's not good. You have to change that. That has to be addressed. Okay, so you're going to do that with the left and for the right. Report your findings. Then you're going to tack it up. Once you have it tacked, you need to take a couple of measurements. The first measurement that you need to take, but not put on the inspection report, is this root opening here at the top. Because in the spec, I've noted that there's a maximum finished width of 25% larger than the actual root face. So if this is, what do we got here? This has a measurement of about 12 to 13 millimeters. Okay, this comes up at about 12 to 13 millimeters. So you take, we'll call it 13 millimeters multiply it by 1.25, and if your finished weld is wider than 1.25 of that 13 millimeters, then if it's wider than that, then it needs to be noted, okay? So take that measurement. You're gonna do it here as well. So take that measurement, then you're going to check your root opening, and that can easily be found by simply taking either your cam gauge or a ruler or a scale, and just count the gradients in between on your holes, okay? See how much of a root opening you've got. Report your findings. You can also check for misalignment. Flip it over the other way. There we go. Check for your misalignment. And you can check them at the tacks. That gives you 4 good points, and you know they should be equally spaced, right? That comes up as 0. That comes up as 0. Technically, that should mean the other 2 are 0, but there's no harm in checking to make sure. Right? There are tolerances in your pipes. That comes up as 0. That comes up as 0. So you've now measured your root faces, right? Your groove angle, your root opening, your top, the top measurement, right? And you've checked for misalignment, and you report those on the spreadsheet. So that is the fit up and the prep for the pipe. Now we'll do the plate. The one thing that I'm going to note, and this is in both cases, okay? Not so much in this, because in a lot of cases you have to prep your own pipes, but the plates that you are supplied with for CWB test plates don't always come super clean. I always prep my own test plates. Why? Because I will actually cut them apart and wire brush the back of them. Even if you were to just take a wire wheel and wire brush the back of it off. This mill scale that sits over here can find its way into the weld and possibly create problems. So if you have an opportunity to eliminate that, absolutely do it, okay? And I do it on both the top and the bottom side, okay? If you don't have that opportunity, and you do it with the bevel side and the square side, I should add. If you don't have that opportunity and you're simply supplied with a plate and you don't have time to cut it apart, clean it, and re-tack it, then at the very least, and this is not really a fantastic example, but you can see that I've taken a wire wheel and cleaned this out. Clean these out to within 1 inch of their lives and go all the way back, same as you see here, okay? Get all that mill scale out of there. Get any possible rust. You can see there's a little bit of rust that's been sitting on this because this has been sitting around forever, right? This has been sitting in a bin somewhere from a previous class, okay? So clean them up as much as you can before you do your test. So back to measuring. So you're going to take your pieces, your individual pieces of your plate pieces, and you're going to measure your bevel angle. Okay, that should be 30 degrees, which we have right on the money, 30 degrees. So you're good there. On these plates, there is no root face. When you're dealing with this type of weld joint, there's no root face. So the response to this on your sheet should be either a strike through, just a simple line through it, or an NA, N/A for not applicable, right? Because this does not require a root face. That sheet is for both, but because it covers 2 different things, sometimes information is not required or not applicable, and you just simply make note of that, okay? So no root face on this guy. Take your measurement, 30 degrees, no root face, make note of it. Then you go to your square side. I'll just flip this guy around for the square side, right? Measure it. That comes up as 90. Do you really need to do that? Well, no, but then again, you should know that if this has some sort of funky angle on it, or if it's not perfectly cut, because sometimes these are saw cut, sometimes these are plasma cut. There's any number of ways that these can be prepared. And if the saw blade is dull, if there's a bevel in this, if it's off by a little bit, you should take note of it. And there's nothing wrong even if you were to take a straight edge or even another piece of material, right? That one's saw cut, this one's saw cut, and just compare them. Is it straight? Nice straight line, you're golden. Should do the same with this guy too. Is it straight? Yep, straight, and you're fine. If there's a gap, if there's a warp, make note of it. Right, so there's your piece, your pieces prepped and measured. Write it down on the Excel spreadsheet. Oh, and on the Excel spreadsheet, I don't care if you print it off, write it in, scan it, and send it to me, or whether you fill it in electronically and just send it back to me. That's fine. I do ask that you send a couple of pictures of, not necessarily of the individual pieces, but send me a picture of the prepped pieces and a picture of the finished weld. That way I've got something to at least, look at. As an expansion to that, whenever you're having anything officially inspected by an outside inspector, they will take pictures of it. They take pictures of the prep, and they take pictures of the finished weld after they do their inspection to make sure that everything is fine, and they put that in their report. That's why I asked for it. Okay. So now with your CWB plate, you are going to take some measurements. You're going to measure your root opening. This is meant for a flat position, so this should be a 1/2 inch. If you're going to use a horizontal, this needs to be 5/16 of an inch, a little bit narrower. So take your measurements. Measure here, measure there. This has a it's hard to tell in 2D, but it's narrower up here than it is down here. So measure here, report your findings, what your difference is. Okay. Notice too, this plate is lower than this plate. Make note of that as well. In this case, it's not really a big deal because they cut 3/4 of an inch off the ends, but you still have to have 4.5 inches of total width, so you need to take that into account. So really, you're not taking a full 3/4 of an inch off this side, 3/4 inch off this side. You're cheating it one way or the other to maintain that 4.5 in the middle, because you need to have those 3 coupons at 1.5 inches each. Okay. Also take note of any gaps. That's in the spec as well. There's a little bit of a gap here. That is measured by your misalignment, high-low. Okay, put it on the plate, put your cam gauge down. This comes up as about a 32nd of an inch. The spec says, I believe, a 1/16, should be fine. Or I think it says 2 millimeters. I know that everything's in millimeters, and because I'm old enough, everything I do is in fractions, so. All right, so 2 millimeters. All right, so there you go. Oh, yeah, so millimeters is over here. So inches up here, millimeters is down here. So it actually converts it for you. So I'm a 32nd here, or a millimeter. Okay, so it's a millimeter out, so it should be fine. Okay, so you're going to take those measurements, your width at the bottom, width at the top, make note of it. Make sure that you take a measurement of your different, and if there's any differences here, okay, gaps here, and then finally take your measurement from here to here, your outside at your top, because that's going to be your comparison when you're done. Okay, so that's your part measurement, your fit up measurement, and now we'll get to the weld. So this is a finished weld that I did. I threw a couple of curveballs at it so that there's something to actually look at. This is a vertical weld that I did yesterday just to kind of give something to look at, because I didn't have any finished plates that weren't already cut up, flattened, cut up, and bent. So this vertical weld has a couple issues with it. First of all, we've got some width issues. We've got a little bit of undercut on this side. It veers off a little bit on this side. There's a low spot right here. There's a width issue. This pass isn't very straight. It comes up and it actually overlaps further here. We might be over 1/8 here. So, and this would also apply to a finished weld on a piece of pipe, right? But instead of measuring it here, you simply measure it across here. Same sort of deal. So I'm going to measure this. I'm going to look for the highest point. That's going to be right about there. I'm going to check it. All right. There's my highest point right there. I have an overall height, that is just under 1/8, or that's just, not even, just under 3 millimeters. So it just barely passed, just barely. Okay, I've got undercut right here. Well, turn it around, take your cam gauge, spatter all over this too. What on earth? That's not good. Maybe it's not on the spec, but that should be noted that there's excessive spatter on there. All right, measure the spatter. Measure the spatter. Measure the undercut. Find your lowest spot right in there. How does that math out? That comes down below the plate, 1 millimeter. So there's 1 millimeter of undercut. Now I can take a measurement. This being a test plate, that needs to be fixed, because when this is cut up, you can't have anything below the plate, particularly here in the middle, because there's a little bit right there. All right, but in a finished weld, right, that might be acceptable. In a test plate, it isn't, right? So you got 1 millimeter here. So then you would measure. It goes from about there to there. Is that beyond the spec? You would report that. You've got a little bit here, a little bit here, a little bit here. Okay. Then you take your overall width. I have a total width here of about 25, hold that up to the camera. I've got a width of about 25 millimeters, okay? My width here is about 18 millimeters. So I do that math. I can't do that math right now because the camera that I'm using is my phone, which is also my calculator. So hang on a sec. No, the other one's dead. So you have 25 millimeters here, and you have 18 millimeters here. I think that's what I said. 18 millimeters. Okay, so you take your 18, multiply it by 1.25. If that 1.25, add answer of 1.25, is narrower than this dimension right here, across here, that's a problem, and it needs to be addressed. Okay? When you're dealing with roots, I realize that this doesn't have a root on it, but you can measure your root reinforcement, because that is on the inspection. That is simply achieved by putting the cam gauge inside, finding your highest point on the inside of the pipe. Right? Finding the highest point on the inside of the pipe, and I'll just use this tack as an example. All right, nice and straight. And you measure. That says 0, but you should have some reinforcement, and it gives you the information on that. Okay, that gives you that gives you your result on that. Like I said, if there's anything else that is egregious, like the excessive spatter, that can be noted. It's not in the spec, but it can be noted as excessive spatter left on plate. Okay, just put it in down at the very end after the welder. There's a couple of blank spaces. You can add that in, excessive spatter. Is it acceptable? It just can be noted, right? It's not necessarily an unacceptable thing. It's a workmanship issue that should be cleaned up, and you just simply say, hey, can we get this spatter cleaned up so that I don't open myself up, cut myself on the spatter, because that does happen. You can cut yourself on spatter. Okay, now that should pretty much cover everything. If you have any questions, if there is anything that is not clear in this video, if I have missed anything, if you feel that you need more of an explanation, please reach out to me, email me, david.ray@durhamcollege.ca, and I will get back to you as soon as I possibly can. All right, this is simply a guide. I'm not going to